All right, here we are on the last problem. This is from the 2023 AP Calculus BC exam. This was FRQ number 6, the series question. This was our lowest scoring problem from this set of FRQs, and you can see there was something about this that bothered us. We were only slightly above the Texas average, and we were below the global average, pretty significantly below the half of a point below the global average. That's quite a bit. So we were well above in the other problems, and I think that that's where my students focused their attentions, and it worked out well for them. But we were a little bit below global average on this one. So let's take a look. The function f has derivatives of all orders for all real numbers, and it is known that f of 0 is 2, f prime of 0 is 3, f double prime of x, not 0, but x, is this, and f triple prime of x is this. Okay, what are my thoughts when I just see this? My thoughts are, my center is going to be 0. Yay, I like to have my center of 0. It just makes things clean. So I like my center at 0. I can find f double prime at 0 and f triple prime of 0, but they didn't just give it to me like they did these. Okay, part A. Find the fourth derivative of f with respect to x. So find the fourth derivative. Well, ignore this question. How do you find a fourth derivative? You take the derivative of the third derivative, correct? And they gave me the third derivative. So I can find, they want me to find a fourth derivative and they give me the third derivative? Okay, I can do that. So part A, the third derivative they gave me is negative 2x times f prime of x squared. They gave me that. So therefore the fourth derivative will be, okay, derivative, product rule. I see a product, I'm using the product rule. The derivative of the first thing is negative 2, multiplied by the second thing left alone. Oops. Ugh. And I have it so tiny. I'm trying to write so tiny to fit everything in. Sorry about that. Okay. Plus for product rule. Now the derivative of the second thing. The derivative of the second thing is f double prime of x squared times 2x. That's chain rule. Multiplied by the negative 2x left alone. So that is the fourth derivative of f with respect to x. Now we have to write the fourth degree Taylor polynomial for f about x equals 0. Fourth degree Taylor polynomial. So my mind shifts to a fourth degree Taylor polynomial. I know what that looks like. Centered at 0. F of 0 plus f prime of 0 over 1 factorial times x minus 0 to the first power plus f double prime at 0 over 2 factorial x minus 0 to the second power, etc. Okay? They gave me f prime of 0 and they gave me f of 0. So they gave me these two numbers. And they gave me a way to find everything else. So that's what I'm going to do. So f of 0 is 2. They gave me that. F prime of 0 is 3. They gave me that. F double prime of 0. I'm sorry, f double prime, well, yeah, of 0. I want it of 0, right? I'm putting 0 in for x. I'm going to have negative, can you guys see this? I hope you can see this. Negative f of 0 I'm putting 0 in for x, so negative f of 0. What was f of 0? F of 0 is 2, so this is negative 2, because f of 0 is 2. F triple prime of 0. I'm putting 0 in for this x now, and immediately I get a 0. 0 times whatever, it's going to be 0. So f triple prime of 0 is 0. The fourth derivative at 0. Well, I found the fourth derivative right here. So the fourth derivative at 0 will be negative 2 times f prime of 0. F prime of 0 is 3, plus f double prime of 0. F double prime of 0 is negative 2 times 2 times 0 times negative 2 times 0. Well, that's all just 0. This is going to be a negative 6. So once I have all of my derivatives, I can then write the fourth degree Taylor for f about x equals 0 is, okay, 2 plus 3 over 1 factorial. I'm not going to put over 1 factorial, but it is there. X minus 2 over 2 factorial, which is just 2. X squared plus 0 over 3 factorial, x cubed, minus 6 over 4 factorial, x to the 4th. Or, if I find f in part A, I know I'm going to be using f all throughout this problem. I am not going to leave it like this, because that's going to make it very muddy looking and it's going to confuse me later. So I'm going to write 2 plus 3x minus x squared plus 6 over 4 factorial. 6 over 4 factorial, 4 factorial is 24, yeah? So that would be minus 1 over 4x to the 4th, okay? But since I did clean it up, I'm going to safe stop right here. By boxing in my answer, I'm going to safe stop. Okay, part B. The fourth degree Taylor polynomial for f about 0 is used to approximate f of 0.1. So there's my x value, 0.1. Given that the maximum, the absolute value of the fifth derivative is always less than or equal to 15 between 0 and 0.5, use the Lagrange error bound to show that this approximation is within 1 over 10 to the 5th of the exact value of f of 0.1. Okay, Lagrange error bound. So my mind shifts to Lagrange. Lagrange is max derivative. In this case, the fifth derivative divided by 5 factorial times x minus c to the 5th power. But remember, no x's, c's, f's, no nothing, all numbers, all numbers. The max derivative is 15 over 5 factorial. X is the 0.1, c is the 0. So, in part, I might just put it right here. How about that? Right there. So, I'm going to write that. 15 over 5 factorial times 0.1 minus 0 to the 5th power. Derivative, factorial, power. All must match. All must match. And I'm going to say they want me to say that that is within 1 over 10 to the 5th. So that is within 1 over 10 to the 5th. Okay? Done. That's it. All right, part C. Let g be the function such that g of 0 is 4, g prime of x is e to the x f of x. Write the second degree Taylor polynomial for g about x equals 0. Okay. All right. Well, if they want the second degree Taylor polynomial for g, I'm going to start by doing just a second degree Taylor polynomial for g. G of 0 they gave me is 4. G prime of 0. Well, if this is g prime of x, I can plug in 0 for x, right? So it's going to be e to the 0, f of 0. E to the 0 is 1. F of 0. What is f of 0? They gave me f of 0 is 2. So g prime of 0 is 2. Okay, g double prime. For g, I want g double prime of 0, but first I have to go find g double prime of x. To find g double prime of x, I need to take the derivative of g prime, right? So another product rule. The derivative of e to the x is e to the x, multiplied by the f of x left alone, plus for product rule. Now we're leaving the e to the x alone and multiplying by the derivative of f of x, f prime of x. So g double prime at 0 is e to the 0, which is 1, f of 0 is 2, plus e to the 0 is 1, times f prime of 0. F prime of 0 they gave me was 3. So g double prime of 0 is 5. So that's all we needed for the second degree Taylor. We just need to go up to g double prime. So the second degree Taylor for g about x is equal to 0 is 4 plus 2 over 1 factorial x to the first plus 5 over 2 factorial x squared. And I'm done. They didn't ask me to do anything with it. So it turns out I did not have to clean up f at all. So I might even go back and get rid of that, just in case I did something. Well, I say stop, so it wouldn't matter. Okay? All right. That's it. I wanted to show you guys something, though, because I had a thought. On part C, I had a thought to do this another way. I had a thought, and it would be much longer than this process, but I had a thought to do it where e to the x, let's do this. So e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus on and on and on and on. That's e to the x. F of x is the Taylor polynomial for f, which is right here, right? 2 plus 3x minus x squared plus on and on and on, yeah? On and on and on. That is, that's f of x. Well, if I want the second degree Taylor polynomial for g prime, I want it for g, but the product is g prime. So g prime would be e times f. E times f, right? And I'm stopping at 2, at degree 2, because we just want the second degree Taylor. So g prime would be, okay, 2 plus 3x minus x squared plus 2x plus 3x squared. I'm not going to get an x cubed plus x squared, and anything else would be higher. So, alright, this is 2 plus 5x plus 3x squared. Is that right? Yeah. Okay. And that's g. That's g prime. So to get g, I'll need to integrate both sides. Right? So g would be 2x plus 5 halves x squared plus x cubed, which I don't want an x cubed, so I'm just going to make this approximately equal to, okay, plus c, yeah, plus c. They gave me that g of 0 is 4, so g of 0 would be 0 plus c, and that will be 4, so c is 4. I'm going to move c to the front, and I get g of x is 4 plus 2x plus 5 halves x squared, which is exactly what we got when we did it the other way. This way did take significantly longer, though. Okay, how did they score this? How did they score this? Part A. Part A was worth, let's see, that part A was worth 4 points. 1 point for the form of product rule. Did the student use the product rule to find the fourth derivative? Did they use the product rule? 1 point for the exact fourth derivative of f. 1 point for 2 terms of the polynomial. And 1 point for the remaining terms. Okay. Part B. Part B was worth a total of 2 points. 1 point for the form of the error bound. Lagrange error bound. And 1 point for shows that the error is less than or equal to 1 over 10 to the 5th. Part C, 1 point was given for, find it over here, 1 point was given for g double prime of x, okay? Or if you did it this way, they said 1 point was for finding, was for taking e to the x times f of x, like that. Okay? And getting, 1 point was for getting this right here. Alright, and then 1 point was for the first 2 terms of the second degree polynomial, and 1 point was for the entire Taylor polynomial. Were they all correct? Okay, so a low scoring problem on this one, yeah? A little bit of a different one, but the more we see different problems, the more you will learn to just do what they tell you to do. Just expect the unexpected and just do it.